Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Farhan bin Ahmad Puad and my friend Mohamad Iqmal bin Mamat. So in this video, we are going to explain about the processing methods of confectionery fats. As we know, Malaysia is one of the largest producer in palm oil products. Some of the palm oil products is confectionery fats and also other products. Confectionery fats that we can usually obtain consist of margarines, shortening, and also whipped cream. So this is some of the example of confectionery fats that usually produced from the palm oils. So in this video, I will explain on the extraction stage of the processing of confectionery fats, followed by refining process, which consists of 3 steps, which the gumming process, followed by the second step is neutralization or deacidification, and the last one is bleaching. The other parts on this video will be explained by my friend Mohamad Iqmal on deodorization stage of the confectionery fats processing. The first stage of processing of confectionery fats is extraction process. In this process, the common method that usually used during the processing of confectionery fats, especially on the extraction process, is a solvent-solvent extraction. During the solvent-solvent extraction, oil, neat or in solution in hexane is extracted in a counter-current process against a solvent, typically methanol and also ethanol. Depending on the solvent and the exact condition, the free fatty acid FFA and other some diglycerides are extracted into the alcoholic stream, and the acidified oil will flows out as the other stream. The refining losses are very low from this process of extraction methods, and the cost of the process can be justified by the increase in yield of the valuable exotic fats. So the next step of the processing of confectionery fats is refining process. The aim of the refining process is to remove the objectionable co-constituent in the oils with the least possible damage to neutral oils and minimal loss of desirable constituent. This process also is to improve the oil quality with better taste and color, and also will produce a high quality of oils. As we can see from the figure by Wong Son in 1991, the figure shows the effect of neutralization on the SFC, solid fat content, melting curve of alaulic confectionery fat, hydrogenated palm kernel stearin. Based on this figure, the refining and also the removal of free fatty acid FFA usually leads to an improvement in the SFC melting curve, which is very significant for alaulic type confectionery fat. As we can see from the figure, as the temperature increase, the percentage of the solid fat content will also decrease. The next part of the processing of confectionery fats is degumming process, which is the first stage of the refining process. The aim of this process is to remove the phosphatates and certain defined slimes or mucilaginous or proteinous materials from the oils, which is called gums. The exotic fats are often high in free fatty acid, which is in range of 10 to 20%, which is not uncommon. This is due to inadequate control during harvesting, storage, and transport of the seed, and also crude fats. They are highly insaturated fatty acids, particularly stearic acids. The second step of refining process is neutralization, or we can say deacidification. In this process, free fatty acid and also residual gum will be removed by a chemical reaction with alkali.
The last step of refining process is bleaching process. During this process, an absorption process to remove coloring pigments such as keratin, chlorophylls, and also other minor impurities like residual phosphatates, soaps, metals, and oxidation products. Adsorption on acid-activated bleaching plays an or active carbon through several adsorption mechanisms such as absorptive properties, acid properties, catalytic properties, and also ion change properties. The second part of this video will be explained by Mohamad Iqmal, and he will explain on deodorization stage of confectionery fat processing. So let's take a look.
Hello guys, Next, we will move on to the oil refining process, which is the deodorization process. Don't you know what is deodorization? Deodorization is the last stage for refining process. It is a quality control process of oils by eliminating the free fatty acid or FFA and any substance that can give off flavor smell. The process usually involves high temperature, high vacuum, and live steam distillation process. Quick info: distillation is a physical and not a chemical process and does not change the molecular structure of the components, which including physical refining to remove FFA. It is carried out at temperatures ranging from 200 to 275 degrees Celsius at 1 to 5 millibar vacuum with steam stripping. Next, let's move on to the effects of this process. It has two effects, which is desirable and undesirable. For the desirable parts, it has three components. Firstly, it gives actual deodorization by removal of different oil flavors. Second, it is stripping of volatile components such as, first, free fatty acid in the case of physical refining. Second is the contaminants, which is the pesticides. And lastly, the thermal destruction of pigments, also called as heat bleaching. Next, from this process, we also have an undesirable effects. It has four effects, which is the first one is the loss of antioxidants to the distillates. Second is the rearrangement of double bonds in polyunsaturated acids. Third is the formation of dimeric and higher polymeric triglycerides. And lastly is the rearrangement of triglycerides. Then, this process' main purpose is the removal of odor. According to Ida 1982, he had studied the production of artifacts during the deodorization process. He concluded that the formation of artifacts was not significant below 240 degrees Celsius. Removal of antioxidant is generally undesirable for all edible oils and fats, and there are no issues specific to confectionery fats. According to another study from Stanford and Joburg 1996, they said that the extent of removal depends on temperature, vacuum, and the type of deodorizing equipment used, and some uses are inevitable. Then, the isomerism of the double bonds in polyunsaturated acids is of no concerns for confectionery fats. Next, let's discuss the effect of this process to another type of triglycerides, which is the SSO and SOS type of triglycerides. The rearrangement of triglycerides is very undesirable for SOS type confectionery fats. At high temperatures, SOS triglycerides can rearrange to produce SSO and SSS triglycerides, which are particularly undesirable because of their effects on melting and crystallization properties. According to a study from Williams and Petley 1985 on the effects of time and temperature on the ratio of SOS to SSO triglycerides in palm oil, the time and temperature are interdependent. They had studied temperature ranging from 220 degrees Celsius and above. At 220 degrees Celsius, the rearrangement was low and almost negligible up to 2 hours. At 240 degrees Celsius and above, the rearrangement was rapid and progressive. There was a significant increase in SSS and deterioration in the SFC melting curve compared with deodorization at 220 degrees Celsius. According to Wonson 1991, he had studied the effect of deodorization on various SOS type raw materials. From figure 4.2, as we can see, 220 degrees Celsius again seems to be a critical temperature. At 240 degrees Celsius, a noticeable deterioration in the SFIs has occurred, while at 280 degrees Celsius, the deterioration is so bad that the fat would be unusable. It is so important so that even at 280 degrees Celsius after 1 hour, the deterioration was considered less. Next, pesticides give an off flavor to the edible fats. Did you know that tropical fats may contain high levels of pesticides? Fractionation, especially using a solvent, can concentrate pesticides into a byproduct fraction suitable for physical refining at a high temperature, thus removing all pesticides into the distillate. The deodorization temperatures are normally minimized to avoid rearrangement of triglycerides, so there is a balance between effective removal of pesticides and minimum damage to the properties of the fats. Recent studies working with cocoa butter has shown that 200 degrees Celsius in a semi-continuous deodorizer, specially designed for efficient stripping, is an adequate temperature for processing cocoa butter to remove the pesticides, although a completely bland fat may not be produced. There are some past studies of edible oils had been conducted. According to a study from Una et al. 1983, the refining of sunflower oil showed that batch deodorization at 220 degrees Celsius was able to remove more than 90% of 4-chlorinated pesticides. Therefore, what we can conclude here is that it is likely that the normal, relatively mid deodorization conditions up to 220 degrees Celsius used for confectionery fats will remove the majority of pesticides. Certainly, levels of pesticides in refined confectionery fats available in the marketplace do seem to be low to undetectable. Well guys, that's all from us. Thanks for watching.